Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. So today we're going to continue with our chapter 4, and in this part we're going to have a look at the roles of the microorganisms in bioremediation process. So let's see the definition of the bioremediation. Okay, so it is a process in which we introduce the microorganisms, and that microorganism, it will consume and it will break down all the environmental pollutants. Then once they have completed that, then it will be a clean from pollution. So the microorganisms that we use for bioremediation, usually we use the bacteria, fungi and also plants, because these elements, bacteria, fungi and bacteria, fungi and plants, they have the ability to break down or degrade the toxic chemical compounds that are in the environment or that are in the polluted site. So the success stories of bioremediation by using microorganisms, they can clean up the pollutants including the crude oil, gasoline, pesticides, sewage and chlorinated solvents in the cleaning supplies. This is a diagram showing the process of the waste bioremediation, where we can use fungi, plants and bacteria to clean up the polluted area, then towards the achieving green earth. So there are three types of bioremediation. So the first one is in situ bioremediation, then Excito bioremediation, and the last one is Phytoremediation. Okay, so from the name itself, we already know that in situ, it means that the process of bioremediation, it is being done at the place of the pollution. Excito bioremediation, it means that the process of bioremediation is extracted out of the polluted site. Phytoremediation, phyto, it means plants. So it means that the process of remediation, of removing, of breaking down the chemical compounds of the pollutants by using plants. The first type of bioremediation is the in situ. Okay, so from the name itself that we know that we do the bioremediation at the place. Okay, why we do that? Because it is the cheapest and also the most efficient. Within in situ bioremediation, there are two types of in situ bioremediation. The first one is intrinsic bioremediation, and the second one is accelerated bioremediation. Intrinsic bioremediation, it uses the microorganisms that are already present in the environment to biodegrade the harmful contaminant in that site. Okay. In contrast, the accelerated bioremediation is where the substrate or the nutrients are added to the environment to help break down the toxic spill by making the microorganisms grow more rapidly. Okay, so we can see the difference here. Intrinsic is we just let whatever microorganisms that are already present in the environment or at that polluted site to do their job of the bioremediation. However, for the accelerated, where we help them to grow more microorganisms so that more microorganisms, they can degrade more chemical compounds. Second type of bioremediation is the Excito. So as mentioned just now, Excito, it means that we take out the contaminants out of the area of the pollution. So when Excito bioremediation is being chosen, usually we use this process, the Excito bioremediation, where we take out the spills of the contaminant. We don't do that as usual as the in situ bioremediation, because it is expensive. Yeah, because it involves the cost of the transportation, because we have to take out the contaminants, and also it is damaging to the area since the contaminated land is physically removed. So when we want to do the bioremediation, we try to minimize the impact to the environment. And these are the examples of the Excito bioremediation. The third type of bioremediation is phytoremediation. And as mentioned just now, phyto, it means plants. Yeah. So it is a process of remediating, biograding the contaminants by using plants. So it is the process of plants releasing the natural substances through its roots, supplying nutrients to microorganisms in the soil. Then the microorganisms, when they are fully packed of the nutrients, then they can grow bigger, then they can do their job, okay, to degrade, to biodegrade the contaminants in the soil. So within the phytoremediation process, there are a lot of other processes, okay. So it's phytodegradation. It is the use of plants to destroy the organic pollutants. We also have volatilization, okay. So when we convert the metals to the volatile forms. And then we also have phytostimulation, phytofiltration, and so forth. The benefits of bioremediation is it is a lower cost because we already use whatever the microorganisms that are already present in the environment, less disruption of the contaminated environment, and also plants can be easily monitored when we opt for the phytoremediation. However, there are some disadvantages of the bioremediation where not all compounds are biodegradable. It means that not all compounds can be degraded by the bacteria, fungi, or plants. Some of them sometimes because maybe they are too strong or maybe the compounds are very complicated, then we need the help of the chemicals, and also it is time consuming, yeah, because we're dealing with living organisms. So we can't really expedite the process. We can't really tell microorganism, okay, come on, do your work, come on. Okay. So some acknowledgement for these students. Actually, I have a few slides. The slides showing the bacteria, the roles of the bacteria in the bioremediation, but I'm not sure why it is not up here, but I'm going to talk about it anyway. Okay, let's see. So I'm going to give you two examples, yeah, on the roles of the bacteria. Okay, so for example, example 1, okay, Pseudomonas. Pseudomonas, okay. So all these examples have been taken from the journal paper. Okay, so nanti I will give you the journal paper. Well, maybe I will give you the link, the slides with that journal paper. And Pseudomonas, it is helpful in bioremediating the P-nitrophenol. P-nitrophenol. Okay. So P-nitrophenol, or we also know that as PNP, it occurs as the contaminants of the industrial effluents, and it is the most important environmental pollutant, and usually it causes significant health and environmental risk because it's very toxic to many living organisms. So this bacteria, Pseudomonas, it has the ability to break down this P-nitrophenol. Okay, the second example that I'm going to give you is bacteria, for example, again, Pseudomonas as well. What else? Agrobacterium. bacterium. There are Chelatobacter. Okay, so these are among the bacteria. Okay, so these bacteria, they have the ability to degrade S triazines. Okay, right, so S triazines, it is coming from the chlorinated herbicides. Okay, and these S triazines ni, they are very widely distributed in the environment. Yeah, so S triazine, because it is part of the herbicides, so it is usually used in the agriculture and also in the forestry, in all over the world, in the diverse regions of the world. And S triazines ni, they are very toxic because they could act as the endocrine disruptor and they can cause cancer. Okay, so the environmental pollution with this compound ni, S triazines ni, it raises concern and it raises awareness among the community on how to solve this problem. So they have identified few microorganisms, few bacteria that can degrade this compound of S triazine. So besides the Pseudomonas as well, we can use Agrobacterium and also this Chelatobacter. Okay, so I think that's all for today for this part. Thank you very much.